vertex form, and we'll convert vertex form, or we'll convert between vertex form, and I'm going to call it standard form. I don't know that there's really a technical name for this form of a quadratic equation. You'll see it called different things, but I'm going to call this standard form. Y equals ax squared plus bx plus c, and then of course vertex form, y equals a x minus h squared plus k. Okay. There are various reasons you may want to convert between the two of them. Right? Vertex form is really nice for graphing, but it's not as easy for factoring or finding the zeros. Right? So if someone gives you an equation in standard form, you could convert it to vertex form to graph it. Someone gives you an equation in vertex form, you could convert it to standard form to factor it. You always have that option. The other reason you may want to know this is it might show up on a standardized test at some point in your life. So the easiest one, or the easier one, is vertex to standard. So to convert from vertex form to standard form, let's do an example like this. Y equals 2x minus 3 squared plus 7. The first step is going to just be expand that squared thing, right? We want to expand there's a word for it, I can't think of it right now. Expand the perfect square. So x minus 3 squared, there's a couple ways we could expand that. You could use FOIL. Right? So over here I'll just kind of show using FOIL. You would think of it as x minus 3 times x minus 3. So x times x is x squared. X times negative 3 is negative 3x. Negative 3 times x is also negative 3x. And negative 3 times negative 3 is a positive 9. So that's one way. The other way is you might remember we talked about when you have a perfect square like that, you always have a squared plus 2ab. So if this is a and this is b, 2ab would be negative 3 times 2 times x, which is negative 6x. And then b squared. Either way, we get the same thing, because negative 3x minus 3x is negative 6x. The key with this step is please remember to put that in parentheses. This 2 is going to be multiplied times everything inside those parentheses. Okay. And then the next step then is just to distribute. So we have y equals 2x squared minus 12x plus 18 plus 7. And then the last step is to combine like terms. So we have y equals 2x squared minus 12x plus 25. And then you're done. That is now standard form. So there's really two steps. Expand this and then distribute. Because the combine like terms thing I think is pretty natural for us to do. You don't necessarily have to memorize that piece of it. But actually this whole process is pretty intuitive. Right? If you want to get this thing into standard form, it kind of just makes sense to expand this thing that's in parentheses. Because in standard form there are no parentheses. So we must get rid of that somehow. Okay. I want to move right into standard form into vertex form, and then we'll do some mixed practice afterwards on your homework. I'm not going to do another example of this. Let's see. So if we had standard form into vertex form, this one's a little bit trickier. But you already know the trick to do this. I'm going to start with an easy example. So if I have something like this, y equals x squared plus 2x plus 1. I want to recognize that this is a perfect square. Okay. So if I have a perfect square, converting to vertex form is actually pretty easy. All I have to do is factor this, and this becomes x plus 1 squared. And this is vertex form now. Okay? This is vertex form because my a is 1, right? And my k is 0.
It's kind of like when we're finding the perfect square.
Yeah, and we're going to get to that in just a second. So if you have a perfect square already, converting into vertex form is just one step. You just factor it into its perfect square form. The other one that can be easy is if you have no b term. So if I have something like this, y equals 3x squared plus 2, this also is vertex form already. This is just the same thing as y equals 3x plus 0 squared plus 2. Right? So technically this is vertex form, if we just kind of put the x in parentheses. So those are two cases when converting from standard form to vertex form is very simple, just one step. But what if it's not a perfect square, and what if we do have a b term? Then what happens? Well, what did we call it when we had something that wasn't a perfect square and we wanted to make it a perfect square? What was that? Completing the square, yeah, and that's all we're going to do. So what if I have something like y equals x squared plus 5x plus 2? This can be a little bit tricky just in terms of the way that you write it. But what we're going to do is we're going to look at this, and we're going to complete the square with it. Let me change that actually, because 5 is not a very nice number. Let's do 6x. You could do 5, but you'd end up with fractions. So if I have x squared plus 6x, what is the completed square version of that? X squared plus 6x plus something.
9.
Yeah, it has to be 9 because 9 is half of 6 squared. And this is where it gets a little bit weird. I can't just add 9 to this. So what I'm going to do, I have to keep track of my plus 2 that was already there. And then I'm also going to subtract 9. So when I add 9 here, I subtract 9. What did I effectively add then?
Nothing.
0. Yeah, I added 0. So now what we do is we factor this part of it. And this is weird because we're used to, in algebra and like most things that we've done, we work with like two sides of the equation. But with this technique, you kind of are working on one side of the equation and treating it as two separate parts, which is different than anything that we've really done. So I'm just looking at this part of it. If I factor that, I now am going to get x plus what? Plus 3 squared. And then I just have these two numbers off to the side that I combine to make my k term. In this case, minus 7. And that becomes vertex form that way. So the steps here are complete the square. Right? Keep track of constants. And then simple. These are not as prescriptive as the other step, as the other way of doing this, right? From vertex form to standard form. It's going to be a little different each time. But the basic thing to remember is we're completing the square with the first two terms. So maybe I should write that. Complete the square with first two terms. And then keep track of these constants. So when I add 9, I remember to subtract 9. That's going to be the thing that is easiest to forget about. It's just, okay, I'm just going to add 9 and then I have a 2 over here. But then you just added 9. You changed it to a totally different quadratic equation. And we are not going to do, pretty sure that I didn't put any examples on your homework. Yeah, we're not going to do any examples where you have a number in front of the x squared here. Like if I had a 3 here, so if I had, an a term, this process gets a little bit more complicated because you have to factor that out of the first two terms before you can complete this one. It's not that much harder, but we're not going to worry about that for now.
We can do that tomorrow.
No, we'll save that for Algebra 2. You'll see this stuff again in Algebra 2. But I think this is enough for the vertex stuff. Any questions about this process?